Alright, I'll be completely honest, I don't know how to pronounce the teacher's name, so we'll just call her Mrs. P for my sake and yours. So, Mrs. P recorded 50 of her students' data on a dot plot. So, based on the data she collected, we're going to figure out what is the mean and standard deviation of the data. That's where we're going to start. Super easy stuff. So our mean is going to be 81.8. We just get this by adding all of the grades together and then dividing them by the 50 grades that exist. Then our standard deviation is going to be 10.4. Using this information, we're just going to plug it in to the next problem we have. The only difference in the three problems is going to be at one point we're multiplying our standard deviation by 1, 2, and another 0.3. Just by doing that, we simply algebraically solve these problems. Super easy, just use this to plug it in. So, does our data indicate normal distribution? Yeah, I think it does, 100%, yes! But why and how? Well, one super easy way to test if your data actually represents normal distribution is with a box plot. Now, this is a really rough one of the data that we have, but you get the idea. Now, if your box plot is symmetrical around your mean without any outliers, bam! Simple, easy as that. It's a normal distribution. Also, it follows the empirical rule. Now, so let's say we're trying to figure out if you're going to pick at random how likely it was going to be that some of the students, scored 90 or above. Two ways to do this, easy peasy. First of all, we know that it's 15 out of 50, which is 3/10 or 0.3. Alright, and then this slightly more complicated, this one's super easy, but this one, a little bit harder. But, since the empirical rule applies, we use the z-score of 0.7881, and bam, there we go. Alright, so Mrs. P's principal randomly took 5 numbers from 1 to 50, and each one of them correlates with one of the 50 grades. So the 5 random numbers that he picked were 5, 12, 24, 35, and 43. And the numbers that they correlate are right here. Super easy. Just simply the 5th number in our data is 68, our 12th is 72, and so on. So this is just a sample, and our sample mean is 80.6. Now, while this is a sample mean of our data, it does not equal the population mean. As you can see, it's super duper close, but it's not the same because it's just a sample. Now, if, the amount of numbers we took were bigger, maybe go with 10 or 20 instead of just 5, we would get closer and closer to the actual population mean. Easy as that. The only reason that they're not the same is because, 5 is a much smaller number than 50. But still, even though it's not the same, it's super close just with the sample. Alrighty, well that's all I got. See you on the flip side.